Every year, billions of pencils are manufactured, sold, and used across the globe. In the United States alone, it is estimated that nearly 2 billion pencils find their way into homes, schools, and offices annually, while worldwide the number is closer to 14 billion. For such a simple object, the pencil has left an incredible mark on human history, education, art, and communication. But the real question is, how does this modest tool, often taken for granted, come into existence? What is the journey of a pencil from the raw elements of the earth to the sharpened instrument we hold in our hands? The story is far more intricate than most imagine, blending natural resources, chemistry, engineering, and centuries of innovation into one seamless process. The journey begins deep underground, where one of the pencil's most vital ingredients is found: graphite. This dark, carbon-rich mineral is the reason pencils leave their familiar marks on paper. Graphite is mined from deposits across the world, with particularly high-quality vein graphite sourced from Sri Lanka and Madagascar. Its silky texture, ability to leave smooth black traces, and natural abundance made it a perfect candidate for writing long before the pencil, as we know it existed. Centuries ago, pure blocks of graphite were used directly, wrapped in string or encased in wood to prevent staining the fingers. But pure graphite was soft, fragile, and prone to smudging, and supply was inconsistent. This is where another ingredient, clay, comes into play. Clay is not merely filler. It is the secret to controlling how a pencil writes. The blend of graphite and clay determines whether a pencil produces a soft, dark line or a hard, faint one. More graphite in the mix makes the core softer and darker, excellent for shading and art, while a higher clay content produces a harder, lighter core ideal for technical drawing or precise writing. To this day, the familiar system of HB, 2B, 4B, and so on is based on the ratio of these two simple materials. Both graphite and clay are ground down into extremely fine powders, mixed with water, and blended into a smooth, even paste. It was the French chemist Nicolas Jacques Cony in the late 18th century who perfected this method. Faced with a shortage of high-quality English graphite during wartime, he experimented with combining powdered graphite and clay, then firing the mixture in a kiln. The result was a strong, reliable writing core that could be tailored to different hardness levels. His discovery revolutionized the pencil industry, and remarkably, the very same process remains in use today. The paste is carefully extruded through machines that shape it into long, thin rods. These delicate strands, often referred to as leads even though they contain no actual lead, are cut into lengths corresponding to the final pencil size. Once cut, the rods are baked in large kilns, where heat hardens them into durable cores capable of withstanding everyday use. Each rod must be flawless, free of cracks or bubbles, because even the smallest imperfection could cause a pencil to snap under the pressure of writing. While the core of the pencil is vital, it cannot function without the protective and supportive roll of wood. And for this, one species of tree has been prized above all others: cedar. Specifically, California incense cedar has long been considered the perfect wood for pencils. It is soft enough to be cut smoothly by sharpeners, strong enough to hold shape without splintering, and it carries a pleasant natural aroma. Unlike other woods, cedar does not warp or twist easily, ensuring that the delicate graphite inside stays safe. Historically, vast forests of cedar were harvested for this very purpose, but in modern times, manufacturers rely on carefully managed and sustainable forestry practices to preserve these valuable resources. Trees are planted, grown, and harvested in cycles designed to replenish what is used, ensuring that pencils can continue to be produced without depleting the environment. Once harvested, logs are transported to mills where they are cut into long, narrow slats. These slats are dried, treated, and sometimes stained or waxed to reduce warping and improve the look of the final product. A typical slat measures around 7 inches long, just under 3 inches wide, and 1/4 of an inch thick. Perfect dimensions for holding a row of pencil cores. Inside factories, These slats begin their transformation into the familiar body of a pencil. Machines carve a series of grooves lengthwise along each slat, creating channels that will cradle the graphite rods. At this stage, precision is crucial. The grooves must be perfectly aligned and evenly spaced, because even a tiny deviation could result in misaligned cores and wasted material. Glue is applied into each groove, and the baked graphite rods are carefully placed in. Workers and automated systems alike ensure that every rod sits snugly in its channel, ready for the next step. Another slat, also grooved but without graphite, is then glued on top. The result resembles a sandwich. Wood on the outside, graphite in the middle. These sandwiches are stacked into hydraulic presses, where strong pressure clamps them together until the glue is completely dry. Once hardened, the sandwiches are fed into shaping machines that cut them into the classic form of a pencil. The hexagonal shape, which has become the most popular worldwide, is not only iconic but practical. It provides an ergonomic grip, makes pencils easier to hold for long periods, and prevents them from rolling off desks. Some pencils are shaped round for certain artistic uses, but the hexagon remains the dominant design. After shaping, the rough pencils are smoothed through sanding. This stage removes imperfections, splinters, and rough textures, leaving the surface ready for finishing. The pencils are then coated in layers of lacquer or enamel paint. This step not only makes pencils look polished and attractive, but also protects the wood from moisture and wear. Multiple coats are applied for durability, and between each coat, the pencils are dried and polished to achieve a glossy, uniform appearance. At this point, the pencil is already functional, but many pencils receive one final addition that makes them even more versatile: the eraser. The small pink or gray eraser at the end of many pencils has its own complex manufacturing process. Made from synthetic rubber mixed with pigments and strengthening agents, the rubber is processed through a technique called vulcanization. Under intense heat and pressure, the molecular chains of the rubber are cross-linked, giving the material elasticity, resilience, and durability. This transformation ensures that erasers can withstand repeated friction without crumbling instantly. Once prepared, the rubber is extruded into long cylindrical shapes, then cut into small plugs. These plugs are paired with ferrules, the small metal sleeves that attach erasers to pencils. The ferrules are crimped tightly around the wood at one end of the pencil, holding the eraser plug securely in place. It was an American inventor, Hyman Lipman, who first patented the idea of attaching an eraser directly to a pencil in 1858. Though his patent was later contested and sold, the innovation stuck, and it remains one of the defining features of the modern pencil. With the main body complete, pencils enter the final stage: quality control and packaging. Along conveyor belts, workers and machines inspect thousands of pencils for defects. Some are sharpened and tested to ensure the cores are centered and write smoothly. Pencils that fail, perhaps due to cracked wood, off-center graphite, or poor adhesion, are discarded. The surviving pencils are sorted into batches, packed into boxes, and prepared for distribution. Bulk packaging is used for wholesalers and large shipments, while smaller, branded packs are created for retail sales. Labels, barcodes, and sometimes decorative designs are added depending on the target market. By the time the process is complete, what was once raw carbon in the earth, clay in quarries, and towering cedar in the forest has been transformed into a familiar, reliable tool. The pencil has journeyed from natural resources to industrial craftsmanship, bridging centuries of human knowledge and innovation. Even in today's digital world, where keyboards and screens dominate communication, the humble pencil continues to thrive, with the industry valued at nearly $16 billion globally and expected to keep growing. Its survival speaks not only to nostalgia, but also to its enduring practicality. So the next time you pick up a pencil, pause for a moment. Consider the journey of the graphite mined from the earth, the clay refined for precision, the cedar that grew for decades before being milled, the machines that pressed and shaped it, and the workers who ensured it met the standards of quality. What seems like a simple stick of wood with a dark center is in reality the product of centuries of refinement and countless hands.